Alright, today we're looking at Charles' law. This is also welcoming you to School of Chemistry. If it's your first time, do not forget to subscribe. Alright, Charles' law actually look at the relationship between temperature and volume. And the law states that the volume of a given mass of gas is directly proportional to its temperature in Kelvin, provided that the pressure remains constant. That is to say, if the volume goes high, the temperature must go high. If the volume reduces, the temperature too will reduce. That's why they are directly related. So if you're having a big volume, you must have a big temperature. But the thing there is, as a matter of emphasis, that temperature must be what? Kelvin. So do not forget that to convert from your Celsius temperature, T in Celsius, to Kelvin temperature, what do? You're going to add T Celsius plus what? 273. Now if you are converting your Celsius temperature to Kelvin, you do what? Your temperature is Celsius, you add what? 273 to it. To have what? Your temperature in what? Kelvin. You must not forget that. Alright. So they say that the volume of a given mass of gas is directly proportional to its temperature in Kelvin, provided the pressure remains what? Constant. Now, what that means is, anytime you have a triangle like this, what that means is, if you have a small volume, it means the temperature is small. If you have a bigger volume, it means the temperature will also increase and become what? Bigger. So the bigger the temperature, the bigger the volume. The smaller the temperature, the smaller the volume. So I'll call this V1, T1, V2, T2. So mathematically we can say that V is directly proportional to T when P is what? The constant. So that V will be equal to KT, to remove the proportionality sign, so that V over T will be equal to K. It means that at instance 1 and instance 2, comparing them, we'll have that V1 all over T1 will be equal to V2 all over T2. And this is a statement of Charles' law. Either represented like this or like this. Either one, you're correct mathematically. So if you cannot represent this as a definition in words, this is also a definition mathematically. Make sure you define each of these terms, where V is what? Volume. T is temperature. Temperature in Kelvin. Remember that, in Kelvin. And P is what? Pressure. Let's look at an example. At 17 degrees Celsius, a sample of hydrogen gas occupies 125 cm3. What would the volume be at 100 degrees Celsius if the pressure remained constant? This is a statement of Charles' law, a relationship between what? Volume and temperature, so that V1 over T1 will be equal to V2 all over what? T2. We'll get our data. So if you follow that triangle, we'll have it that at 17 degrees Celsius, the volume is what? 125 cm3. So we're looking for, at 100 degrees Celsius, we're looking for what? The volume. So our data now say T1 will be equal to 17 degrees Celsius. And because this temperature is in Celsius, we'll convert it to Kelvin temperature by adding 273. And we're going to have 290 Kelvin. Now, V1 will be equal to 125 cm3. T2 will be equal to 100 degrees Celsius 100 degrees Celsius plus 273, and this equals to 373 Kelvin. We are converting it to Kelvin, that's why we're adding that. We're adding 273, and then we're looking for V2. So that from V1 over T1 equals to V2 over T2. We'll make V2 the subject of formula so that V2 will be equals to V1 over T1. Let's move to the other side. Well, let me just clean this side. Okay, this is 290 Kelvin, 373 Kelvin. So from here, we'll make V2 the subject of the formula. We'll have V2 will be equals to, take this to this side. You have V1 over T1 multiplied by what? T2. So that V2 now will be equals to V1. Our V1 is 125 multiplied by T2. Our T2 is 373 divided by what? Divided by T1. And our T1 is 290 Kelvin. Press your calculator and give us an answer. If you press your calculator very well, you are going to get 161 cm3 as the final answer. And that's going to be the volume at when the temperature of 100 degrees Celsius. If you have any question, ask in the comment section, and any contribution, drop it in the comment section. Our team will attend to it immediately. Do not forget to subscribe.